Hello students, in the video we are going to look at the past year NEET questions from the chapter Thermodynamics of Chemistry. So this is the part 2 video. Already we did one part 1. So those who are looking at this video, right, maybe you can take a look at the part 1 also, and the relevant models of questions you will be able to correlate them better. Okay. So we'll start with a question from 2015. So the heat of combustion of carbon, if you take 1 mole of carbon and burn this in the supply of oxygen, then we are going to get carbon dioxide. Okay, so that is what we call as the heat of combustion. Heat of combustion of any substance means what? The heat released or the energy exchange involved in the combustion of 1 mole of the substance. Adha heat of combustion and solo. Okay, so heat of combustion of carbon is what? Minus 393.5 kilojoules per mole. Okay, so because this will be per mole. So Pata, what is it? If you take 1 mole of carbon solid, you burn it in the presence of oxygen, burn panna, then the enthalpy change for that is what? Minus 393.5 kilojoule. Okay, va? The heat released upon formation of 35.5 grams of CO2 from carbon and oxygen gas means 35.2 grams of CO2 nama form pannambodu. What is the heat that is released? So they are asking what is the heat that is being released. Okay, va? So then what is the thing? If you look at this heat of combustion of carbon, right? 1 mole of carbon we are doing combustion means we are going to get exactly 1 mole of CO2. 1 mole of CO2 anedi 44 grams of CO2. What is the molar mass of CO2? Carbon 12 plus 2 oxygens, 2 into 16. So anedi what is the total? It is what? 44 grams. That is the molar mass of CO2. Okay, so 44 grams of CO2 adu form agadilla. Then what is the amount of, say, del H negative means what? It is releasing. When it is formed, it is releasing how much of that energy? 393.5 kilojoules. When we are forming 44 grams of CO2. Adana. So when for the reaction del H negative and so now, what does it imply? It implies that much amount of energy is being released. Okay. So paranga, this basically tells us what? The 44 grams of CO2 form agadilla, we are getting 393.5 kilojoules of energy that is being released. Okay, va? But to form 35.2 grams of CO2, how much energy will be released? So then it's like a basic mathematics question. 44 grams. So paraga 44 grams forming means how much energy is released? 393.5 kilojoules. 35.2 grams what is the energy that is released? Okay, so how do you solve this? Proportion basis. Paranga, what is the amount of energy released in the formation of 35 grams of CO2? It will be what? 393.5 by 44 into 35.2 proportion. Okay, so 393.5 is coming when you are doing the formation of 44 grams of CO2. Okay, 35.2 grams, what is the energy that is being released? Okay, so per gram ever release 44 grams you are getting 393.5, right? So per gram it will be what? 393.5 by 44. This is per gram. How many grams we are requiring? And the value we multiply pananu. So what is the amount of heat released? 393.5 divided by 44 into 35.2. So simplify panna, it will be coming as what? 314.8. Approximately we can say, what is it? 315 kilojoule. Unit will be in kilojoules. Okay, so like always in the thermodynamics problems we have to be careful with the sign part. Plus minus nama careful because you see option A paranga plus 315, option D they are giving minus 315. We have to be careful about these things because remember 44 grams of CO2 and the form pannambodu, what is the amount of energy released? Why are we saying energy released? Because the combustion of carbon, right, is exothermic. So then the exothermic, delta H negative means what? Exothermic means our amount of energy 393.5 kilojoules of energy is released when we are forming 44 grams of CO2. then what is the amount of released when we are forming 35.2 grams of CO2. That's the question. Okay va? So this is mostly like a proportion relation question. These kind of questions we also will have in the basic concepts of chemistry. At the question paranga, this is the question that has come in the 2014. Which of the following statements is correct for the spontaneous adsorption of a gas? Suppose you take a solid surface edutittu adula let us assume the gas particles are coming and getting adsorbed. Adsorption enna theriyuma? Adsorption we can see it like a condensation madri. Yeah, because the particles of the gas from the in the gaseous state they are settling on the surface of the solid, right? Means what it is like condensation. So this process, right, particles are coming from the gaseous state to the surface of solid. So entropy will be decreasing, isn't it? And the gas state or vapor state the entropy will be what? More. When they are coming and settling on the surface of the solid means what? The entropy is basically decreasing. So adsorption will be an entropy change negative process. And the particles are coming from the gaseous state they are coming and settling on surface of solid, right? So adsorption is what? Always physical adsorption or chemical adsorption. Adsorption is what? Entropy negative change process. Entropy will be decreasing. Okay va? Now spontaneous adsorption and sonna enadhi? Spontaneous adsorption means and the process of the overall del G must be what? Negative. The process of the overall del G must be what? Negative. Okay, so paranga the Gibbs-Helmholtz equation adana del G value anna what is it? Del G is equal del H minus T delta S. Okay, so idila already del S evla negative because adsorption, any adsorption, physical adsorption agatum or chemical adsorption agatum, delta S will be what? Negative. Okay, oh delta S negative and sonna look at it, then the minus, so minus into minus overall it will become what? The second term. So we can look at like this. The del G or Gibbs-Helmholtz equation del G will have two parts. First part another delta H, second part another minus T delta S. Okay va? The second part is coming as what? Positive varadu. Because del S is negative. Del S is negative the second term is becoming what? Positive. Spontaneous we are looking for spontaneous means what? And the first term should be negative. It should not be just negative. Why? It should be very much negative. It should be overcoming this second term at a positive value. Apadana overall del G will become negative. Overall del G should become negative, right? So and the delta H should be highly negative. Paranga, what is the thing? For the adsorption, right, entropy will be decreasing, which means what? Delta S will be negative. Okay va? And we are saying spontaneous adsorption sonna the del G must be negative. Adukku what is the requirement we need to have? And the delta H value, right, should be highly negative. Edukku highly negative? Because it should dominate the positive value of the second term. Second term enadi minus T delta S. Paranga enga irukku option B paranga del S is negative because any adsorption delta S will be negative. Okay va? And to make the overall process spontaneous, they are asking us what? The overall process will be what? Spontaneous. Adukku what is the requirement? The delta H value, enthalpy change value should be what? Highly negative. Appada we will have our del G becoming negative. Okay, so what is the correct answer for this? Option B. In the Madri questions, these are all the theoretical analysis type of questions. You will see that sometimes they will be linking thermodynamics with the surface chemistry, thermodynamics with electrochemistry, thermodynamics with equilibrium. Link pannidi you will have these theory based questions. Okay, another question paranga. This is the question that has come in the 2014. For the reaction X2O4, see, whenever a reaction is given to us, right, focus enga theriyuma, you will have to also look at the phase. Okay, so paranga idla X2O4 is in which state? In the state like the liquid state. Okay, giving rise to 2XO2 gas means reactant, and the reactant is a liquid, product is a gas. Adla they are giving us del U or a value, del U or del E. What is this symbol representing? This is representing what? Change in internal energy dana. change in internal energy. So ஒரு சில இதில் என்னன்னா they will be giving U as a symbol for internal energy. Sometimes they might give E, but we should be knowing. So U or E both are representing what? Internal energy oda symbols. Okay va? So for that particular reaction enna kuduthirukanga, they are giving us change in internal energy. Okay, adukaprom delta S also they are giving, but you have to be careful about the units. Paranga del U oda unit enna kilocalories, delta S unit lo what you are having calories irukka. Okay, at 300 Kelvin நம்ம என்ன find out பண்ணனும், we should find out the del G oda value. Okay, so del G formula enna and Gibbs Helmholtz equation, right? Del G is equal to what? Del H minus T del S. இதில் நமக்கு temperature தெரியும், temperature is given to us, right? delta S oda value தெரியும், but இந்த delta H value தெரியாது. எப்படி delta H find out பண்றது? We have for any chemical equation, right? Delta H is equal to what? Delta U plus del Ng RT. Correct dana? What is delta H oda value? Delta H is equal to what? Delta U, which is change in internal energy plus del Ng RT. And the del Ng another change in number of gaseous moles for the reaction. Product side gas moles minus reactant side gas moles. Okay va? So first what we are going to do, we will find out delta H. Okay, so delta H another del U plus del Ng RT. Okay, so paranga del U, what is the value of del U? 2.1 kilocalories. Del Ng evla? Look at this, product side what is the number of gas moles? 2. Because we have 2 moles of X2O2 gas. Reactant side la paranga, reactant side la gas e kadiyadu. Reactant side la we don't even gas. Yenna reactant is what? Liquid. So what are we going to take? Reactant side la number of gas moles is what? 0. So apannadi del Ng will be equal to what? 2 minus 0, which is equal to 2. Okay va? So del Ng value enna 2, and formula la R varum. So R is what? The value of R in terms of calories enna theriyuma? R is approximately 2 calorie per mole per Kelvin. Okay, but already delta U எதில் இருக்கா? கிலோ கேலரிஸில் இருக்கா. ஸோ இதே நம்ம கிலோ கேலரியில் மாற்றி we should substitute. ஸோ கிலோ கேலரி மாற்றோம்னா we should multiply by what? 10 power minus 3. ஓகேவா? ஸோ the value of R in terms of கிலோ கேலரிஸ் எவ்வளோ? 2 into 10 power minus 3. ஓகே, டெம்பரேச்சர் என்னது? 300 Kelvin. ஸோ அப்படியே நம்ம எடுத்துகிட்டு சப்ஸ்டியூட் பண்ணணும். ஸோ வாட் இஸ் இட்? del H is equal to delta U, delta U எவ்வளோ? 2.1. ஓகேவா? ப்ளஸ் del Ng எவ்வளோ? 2 into R, R value என்ன? 2 into 10 power minus 3 into temperature எவ்வளோ? 300. So இந்த final value எந்த யூனிட் வரும்? கிலோ கேலரிஸில் வரும், because everything we are taking into what? கிலோ கேலரிஸில் தானா? ஓகே, ஸோ பாருங்க, this 2 2s are what? 4. அதுக்கப்புறம் 4 into 300 எவ்வளோ? 1200. 1200 into 10 power minus 3 means என்னது? 1.2 வரும். ஸோ 1.2 plus 2.1 3.3 overall. ஓகே, so del H oda value anadi 3.3 kilocalories. Okay, del H vanadukapram what you are supposed to do? Namak enna venum? Finally question enna kekranga, they are asking del G, right? So appo enna pannom, and del H oda value eduthu apdiye idhula substitute pananum. Okay, but அந்த substitute பண்றதுக்கு முன்னாடி just think about it. இது என்னது? 3.3 kilocalories. but delta S oda value பாருங்க, what is delta S? 20 calories ல வருது. so we should change this into what? அதே நம்ம கிலோ கேலரிஸ்ல மாத்தணும். கிலோ கேலரிஸ்ல எப்படி சேஞ்ச் பண்றது? just multiply by 10 power minus 3. 10 power minus 3 multiply panna it will be what? in kilocalories unit. Paranga, I'll just erase this part. Okay, so del G, Gibbs Helmholtz equation, right? Del G is equal to what? Del H minus T del S. So del S என்னது? 20 calorie per Kelvin, but நம்ம கிலோ கேலரிஸில் சேஞ்ச் பண்ணணும். ஸோ இட் will be what? 20 into 10 power minus 3 கிலோ கேலரிஸ் per Kelvin வருது. ஓகேவா? அதுக்கப்புறம் we have to just substitute. ஸோ del H எவ்வளோ? 3.3 கிலோ கேலரிஸ். ஓகே, மைனஸ் del S into T or T del S. டெம்பரேச்சர் எவ்வளோ? 300 into del S எவ்வளோ? 20 10 power minus 3. பாருங்க, what is it? This is 6 into 10 power 3 வரும். ஏன்னா 320 is what? 6000. ஓகே, இந்த 10 power minus 3 10 power 3 cancel ஆகிடும். ஸோ what is it? 3.3 minus 6 and சொன்னா what is it? minus 2.7. so 3.3 minus 6 எவ்வளவு? it will be what? minus 2.7 kilocalories. unit is what? kilocalories. okay va? so this is our final delta G oda value, which means this reaction is going to be what? spontaneous dana ena del G is coming negative means what it will be spontaneous. So what is the answer for this? Option B. idhula enna nama panirukom first they are not giving us delta H oda value. So on the delta H and delta U and the relation landu we are finding delta H value first, adukaprom we are substituting in the Gibbs-Helmholtz equation. But in the madri questions enna theriyuma, we have seen in previous cases also, generally on the delta H or delta U, those quantities are in which unit? Kilojoules la illana kilocalories la they are giving. But delta S they are giving in what? Joules illana calories. So on the conversion nama paakano. Okay, so we have to be careful about that, illana we will be getting completely wrong answer. Okay, after the question pola, this is a question that has come in the NEET 2013. A reaction having equal energies of activation for the forward and reverse reaction has another reaction having equal energy of activation, then you know what will be the corresponding information. So what they are talking about, they are talking about the del H, they are talking about the delta S order value, they are talking about the del G order value. Okay, so we have to comment on what are these things. So paranga, if you have any chemical reaction, right, this is what we call as the energy diagram and solvom. Okay, so what do you call it as? We'll call it as what? The energy diagram. So we'll use this in chemical kinetics chapter liyum, adukaprom we'll also use this in surface chemistry when we talk about the importance of the catalyst. Okay va? So paranga, or sample reaction H2 plus I2 gives rise to 2HI. idhula the energy difference between the reactants and the intermediate or activated complex and solla, and the rendu naduvula energy difference, right? What do you call it as? Energy of activation for the forward reaction. What? Energy of activation for the forward. Okay va? Andha madri if you have a reverse reaction also happening, right, the energy difference between the products and that intermediate is called as what? The energy of activation for the backward reaction. So forward reaction lo you will have energy of activation, and the madri backward reaction lo you will have energy of activation. The relation between and the forward reaction of activation energy, backward reaction activation energy, and delta H, another delta H will be equal to forward reaction idana forward reaction oda activation energy minus the backward illana reverse reaction. So backward enna sollala, ingonnu word enna sollala, we can call it as what? Reverse reaction. So delta H value for any chemical reaction, right, delta H value another it will be what? The forward reaction or activation energy minus backward reaction activation energy. What is the information they are giving us? Paranga, a reaction having equal energies of activation for the forward and the reverse. Then what will be the delta H value? Delta H is what? The forward reaction activation energy minus backward reaction. If these two are same, delta H value it will become what? 0. Okay va? So what is the delta H value? It will be what? 0. Now we will not be able to comment on what is the del S. Del S பத்தி நம்ம comment பண்ண முடியாது. ஏன் தெரியுமா? Del S will depend upon what is the change in the number of the gaseous particles. So if in the reaction paranga, or you take some other reaction, right, it depends upon what is the change in the number of gaseous particles. So we will not be able to comment on the del S value based upon this information. Verum and the delta H பத்தி மட்டும் தான் we will be able to comment on it. Why? Because delta H is related to the forward reaction or activation energy and backward reaction activation energy. Okay va? So if we are not able to know about delta S means del G பத்தி நம்ம சொல்ல முடியாது. ஏன்னா del G is equal to what? Del H minus T delta S, right? So del H is 0. அப்போ del G ஓட value என்னது? Del G is equal to minus T del S. Okay. இப்போ del S ஏதாவது value இருந்துன்னு வெச்சுக்கோங்க, then del G also will have some value. Okay. So what is the correct answer என்னது? வெறும் del H மட்டும் it will be equal to 0. Delta S பத்தி as well as del G பத்தி நம்ம comment பண்ண முடியாது. Why? Because the information is only about the activation energies. Delta S is related to what? It is related to randomness, right? It depends upon the number of particles. Next paranga, we have a question from NEET Karnataka paper 2013 lande. Okay, another 3 thermochemical equations are given below. So first equation paranga, carbon graphite react with oxygen to give CO2. That is what? Combustion of carbon graphite. Okay, adukana what is the delta H value? X kilojoule per mole. second equation in a carbon graphite reacting with half a mole of oxygen to produce CO. Okay va? Adukana what is the delta H for that reaction? Y kilojoule per mole. Other than equation 3, carbon monoxide gas plus half a mole of O2 giving rise to CO2. For the delta H over Z. Based on the above equations, find out which of the relationship given below is correct. Okay, so this is a question based on the Hess law of constant heat summation. How do we solve this? When you have a set of reactions or equations, the sum of Hess law, what is the Hess law concept? Sum of enthalpy changes. Sum of enthalpy changes of the individual reactions. Individual reactions on the different reactions that we'll collect together. Okay, sum of the enthalpy changes of the individual reactions will be equal to enthalpy change of overall reaction. So the sum of enthalpy changes of the individual reactions will be equal to the enthalpy change of the overall reaction. So இப்போ நம்ம என்ன பண்ணணும், இருக்க reactionsல we have to find out what is the relation between them. பாருங்க, if you do carbon graphite, okay, so GN சொன்னா graphite, okay வா? So carbon graphite is the second equation plus half a mole of O2 gives rise to CO gas. அதுக்கான what is that delta H ஓட value? Delta H is equal to what? Y. Okay, units நம்ம அப்புறம் பார்க்கலாம். Third equation என்ன பாருங்க, carbon monoxide gas plus half O2 gas gives rise to what? CO2 gas. So இதுக்கான what is the delta H value? Third, Z. Okay வா? இப்போ நம்ம இந்த ரெண்டு equations add பண்ண என்ன வரும் பாருங்க, இந்த carbon monoxide cancel ஆயிடும். half O2 plus half O2 எவ்வளவு? O2. Okay, so என்ன வரும்? Carbon graphite, okay வா, plus O2 gas gives rise to, right side என்ன வரும்? Reactant side CO2 gas. This is what is our equation 1. பாருங்க, equation 1 தானா, which means what? நம்ம அந்த second equation third equation add பண்ணா that is giving us the first equation. இப்போ first equation என்ன தெரியுமா? This is the overall equation. The second equation and third equation இது எப்படி? These are the individual equations. Okay வா? So what is the Hess law saying? The enthalpy change of the overall equation, அதன the X is equal to sum of the enthalpy changes of the individual reactions. Means what? The enthalpy change of the second reaction is Y, enthalpy change of the third reaction is Z, which means X is equal to Y plus Z. So what is the answer for this, guys? X is equal to what? Y plus Z, which is option B. Okay, another question paranga. This is a question that has come in the 2012 paper. In which of the following reactions the standard entropy change del S naught is positive and standard Gibbs energy change decreases sharply with increasing temperature? First they are putting the condition, delta S naught, standard entropy change should be positive, and they are saying something about the Gibbs free energy change. So Gibbs free energy change, how is it related to the entropy change? By using the Gibbs-Helmholtz equation. Now what is it? Del G is equal to del H minus T del S. Okay va? So இப்போ பாருங்க, standard means we will put del G naught. அவ்வளவுதானா? del G naught is equal to del H naught minus T del S naught. எல்லாத்துக்கும் நம்ம standard values யூஸ் பண்ண போறோம். Okay va? So if delta S positive இருந்தா, so delta S positive means அப்ப என்ன ஆகும்? As temperature is increasing, இப்போ நீங்க second term பாருங்க, இந்த del H ல ரெண்டு terms இருக்கா. What is it? First term is what? Del H. Okay வா? இந்த del G ல ரெண்டு terms வருது. Del G is equal to del H minus T delta S. So del S positive means temperature நம்ம increase பண்ணா, if increase in temperature, right, the second term will become more and more negative. Second term என்ன ஆகும்? The second term is going to become more and more negative. எதுக்கு more and more negative? Because பாருங்க, இப்போ del S value நம்ம ஒரு sample எடுக்கலாம். del S value is 2 joules அப்படி. ஓகேவா? இப்போ temperature நம்ம 300 போட்டா what is it? 300 into minus இருக்கா முன்னாடி. Okay, so minus 300 into எவ்வளவு? 600 minus. if you take the temperature as 400 அப்ப என்ன வரும்? It will be minus 800. If you put the temperature as 500 H, then what happens? Minus 1000. So temperature increase பண்ணும்போது the second term is becoming negative. Second term is becoming negative means what? The del G order value will be keep on decreasing, right? Del G order value will keep on decreasing, which means the condition what they're asking is the delta S order value should be what? Positive. Delta S positive vanda, then you know what it means? The del G order value will be decreasing sharply with increasing temperature. Okay va? Now we got our situation. What is it? namak enna venum? We are looking for the equation where the delta S order value is positive. When delta S will be positive, we can look at the delta S positive when you have product side more number of gas moles than the reactant side. Okay, so eppadi sollana? Delta S can be quantified by using the del Ng value. Exactly nama del Ng vechi nama solla mudiyadu, but we can quantify the delta S by looking at what? Del Ng value. Okay, enga del Ng positive varado, that means what? In that particular case the product side number of gas moles are more, which means what? The entropy there is more. Product side entropy is more. Okay va? So which means we have to look for where the delta Ng is positive. So if enna pananum, look at it. First equation paranga, the product side number of gas moles is what? 1. Reactant side la graphite is a solid, adu nama calculate pannadhu kediyadu. We will only look at the oxygen which is half. So inga enna varum? 1 minus half, which is half. Positive dana? So what? Positive. Okay, now option B paranga, product side number of gas moles evada 1, reactant side la idanadi half, carbon monoxide is also gas only, right? So then is 1, which means 1 minus reactant side anadi 1 plus half evada 3 by 2, so 1 minus 3 by 2 minus half. So idhula we are getting del G negative. Okay, adukku adutha enna? Look at this. C, MgO solid number of gas moles evada 0, product side gas moles kadiyadu, there is only solid. Okay, reactant side la Mg solid, adiyum calculation varadu, verum inda gas mattum varum, which is half. So 0 minus half ennadi idiyum minus da. Option D parunga, product side half a mole of CO2 irukka. Okay, gas. Reactant side la nama graphite we will not include it, so verum inda oxygen mattum. So what is it giving us? Half minus half, which is 0. So only one reaction, ஒரே ஒரு reaction மட்டும் we have what? We have the del Ng coming as what? Positive. என்னது? That is our option A. So what is it? And option A என்னது? Carbon graphite plus half O2 gives rise to CO gas. அதுல the delta Ng is what? Positive. So delta Ng is positive means what? There is an increase in the number of gas moles, right? Which means the entropy also will be increasing. And நம்ம discuss பண்ண மாதிரி, when the entropy is increasing, right? When the entropy is increasing means what? The delta S is positive. Delta S positive means as increase the temperature means del G order value will sharply decrease. Okay, so the increase of temperature will make the second term. The second term del G will have two terms, right? One term is del H, other term is minus T del S. In the particular term will become what? It will become more and more negative. The T delta is munadi we have a minus, right? That's why the second term is going to become more and more negative. Okay, adanala we will see that delta G is going to be decreasing sharply with increasing temperature. Okay va? So what is the answer for this? Only one of these options we have, and the delta S coming as positive. Okay, so how are we finding out delta S coming as positive and solid? Wherever whichever reaction is giving a change in number of gaseous moles positive, adala we are going to have the entropy change also what? Positive. So what is the answer for this one? Option A is the answer. Okay va? Other question paranga, this is a question from the 2012 paper. The enthalpy of fusion of water. Fusion of water and sonnanade, the water from the ice state lende it is converting itself into water in the liquid state. Other than a fusion. Okay, for that and the enthalpy of the value another 1.435 kilocalories per mole. Okay, the molar entropy change for the melting of ice. See, during a phase change, right? Any phase change, entropy, because phase change enna theriyuma, it's a constant temperature process, and madri it's a reversible process. For any phase change, entropy change will be equal to what? Enthalpy of that particular phase change, either fusion agatum or evaporation agatum or sublimation, enthalpy of that particular phase change divided by the temperature. Fusion in the, what is the temperature going to be? The melting point. Evaporation means the temperature is going to be what? The boiling point. Okay. Sublimation means the temperature value will be the temperature where the sublimation is happening. Okay. So idu namak navigation for any phase change process, eppadi and the entropy change calculate pandradhu? Entropy change is equal to what? The enthalpy change for the phase change process divided by the corresponding temperature. Okay va? So inga delta H for the fusion evladhu? 1.435 kilocalories per mole. In options la paatha they are giving everything in terms of calories. Idu eppadi nama calories maathano? We have to multiply this by 1000 or 10 power 3. So in terms of calories evladhu? 1.435 into 10 power 3 calories per mole. Okay. So what is the delta S soda value? This is the fusion process, right? Enthalpy of fusion divided by the fusion temperature or the melting temperature. So the temperature should be on the Kelvin scale. 0 degrees and sonna, what is the value on Kelvin scale? Nama plus 273 pananum. Okay, so what is the value on Kelvin scale? Approximately 273. Okay, so 1.435 in 10 power 3, this is in calories, calorie per mole, divided by 273 Kelvin. Okay, so division panna. So what is the numerator? 1435 divided by 273 calorie per mole Kelvin madri varum. Okay, so 1435 divided by 273 approximately anna it will be 5.26. Idhula enna theriyuma? You look at these options, nama you don't need to calculate up to the last decimal place, adella nama calculate panna thevilla. So enna look at these options, right? Option A la enna iruka? 10.52, option B la 21, option C enna 5.26, option D 0.526. See, 1435 divided by 273 means what? If you take like you know the 1500 by 300 pota, that is what? 5, which means this is somewhere around 5. So apdi nama we can just round off on the answer. We don't need to calculate it up to the last decimal place, adella namaku thevilla. Okay va? So this is how we will be able to save time in some questions. Enga namak indha madri oru situation varudha, we will be able to save the time while doing questions like this. Okay va? So what is the correct answer for this? Option C is the right answer. அடுத்த question பார்க்கலாம். What is the next one? This is a question that has come in the NEET paper 2013 Karnataka paper la. Okay va? So when 5 liters of a gas mixture of methane and propane, so methane enna CH4, propane enna C3H8. Okay, idoda mixture volume da namakku theriyum. What is it? 5 liters is perfectly combusted at 0 degrees Celsius temperature and 1 atmosphere pressure. 16 liters of oxygen at the same temperature and pressure is consumed. And the combustion la, what is the amount of oxygen that is consumed? 16 liters of the oxygen is consumed. Okay va? Adulandi nam enna calculate pannom? The amount of heat released from this combustion in kilojoules. In the combustion la, what is the amount of heat released and solid we have to calculate. Okay, adukku they are giving some information. Delta H for the combustion of methane evladhu? 890 kilojoule per mole. And madri delta H for the combustion of propane adevada? 2220 kilojoule per mole. See, first enna theriyuma? We should write down combustion equations of methane and madri propane. So what is the combustion equation of methane? Balanced equation eduthanum. Okay, so combustion equation of methane means the combustion kappuram we are going to get what? Carbon dioxide varum, water vapor. Okay va? And madri C3H8 combustion panna adulandi we are going to get what? 3 moles of CO2 and 4 moles of water. Balance panna you are going to get two things. For every 1 mole of methane, adukaga you will be requiring 2 moles of O2. Evada oxygen thevapadum, it will be requiring 2 moles of O2. Okay, and for 1 mole of propane, adukaga you will be requiring 5 moles of O2. Okay va? Balanced equation and what is the information we have for the combustion of 1 mole of methane? Adukku we will be requiring 2 moles of oxygen, double. அந்த மாதிரி for the combustion of 1 mole of propane அதுக்கு எவ்வளவு ஆக்சிஜன் தேவைப்படும்? will be requiring 5 moles 5 times. ஓகேவா? so at 0 degrees Celsius and 1 atm pressure 1 mole of any gas 1 mole will occupy 22.4 liters. இதை நம்ம என்ன சொல்லுவோம்? molar volume ன்னு சொல்லுவோம். என்னது? molar volume. ஓகேவா? so 16 liters of oxygen ன்னு சொன்னா we can find out what is the number of moles of oxygen. எப்படி? at any given temperature and condition number of moles formula என்னது? given volume. what is the number of moles oda formula? given volume by molar volume. given volume by molar volume. அப்படிதானா? that is how we can calculate the number of moles of oxygen. எதுக்கு நம்ம number of moles of oxygen calculate பண்ணணும் தெரியுமா? we are going to find out the number of moles of oxygen from the given oxygen oda amount. எவ்வளவு? 16 liters ன்னு கொடுத்திருக்காங்க. ஓகே, அதுக்கப்புறம் from the combustion அந்த ஈக்குவேஷன் ஓட பேலன்ஸ்ட் ஈக்குவேஷன் பேஸ் பண்ணி we will try to relate the amount of methane propane with the amount of oxygen. எப்படின்னு பார்க்கலாம். ஓகே, so look at this. first நம்ம என்ன பண்ண போறோம்? we are getting the number of moles of oxygen. அதுக்கான ஃபார்முலா என்ன? the given volume at that temperature and condition எவ்வளவு? 16 liters divided by molar volume at 0 degrees Celsius temperature and 1 atmosphere pressure எவ்வளவு? 22.4. so 16 by 22.4 divide பண்ணா approximately நமக்கு என்ன வரும்? 0.71 moles வரும். okay, approximately எவ்வளவு? it will be coming as what? 0.71. ஓகேவா? இப்போ என்ன தெரியுமா? what is the total volume of methane and propane? அதோட total volume எவ்வளவு? 5 liters. இதுல இருந்து we can find what is the total number of moles. what is the total number of moles of this mixture? இந்த mixture ஓட total number of moles எவ்வளவு நம்ம calculate பண்ணலாம். எப்படி? same concept, given volume divide by molar volume. okay, so already in the 0.7 என்ன தெரியுமா? this is the number of moles of O2. அதுக்கப்புறம் we can find அந்த mixture methane propane mixture ஓட total number of moles எவ்வளவு? 5 liters which is the given volume கொடுத்துருக்காங்க பாருங்க. when a 5 liter mixture gaseous mixture of methane and propane divided by 22.4 molar volume பண்ணா approximately it is what? 0.22. அதோட approximate value என்ன? it is what? 0.22. okay, so இப்போ என்ன பண்ண போறோம் தெரியுமா? we have to find out what is the amount of methane and what is the amount of propane. எதுக்கு? because we know what is the amount of energy released when 1 mole of methane is undergoing combustion. அந்த மாதிரி we know what is the amount of energy released when 1 mole of propane is undergoing combustion. so if you are able to find out number of moles of methane அந்த மாதிரி number of moles of propane, number of moles of methane and number of moles of propane, இதை நம்ம calculate பண்ணா using this we can find out what is the total amount of heat released in this combustion. okay, so இதுக்கு என்ன தெரியுமா? the total and the mixture ஓட number of moles நமக்கு தெரியும். எவ்வளவு? 0.22. so let us say x is the number of moles of methane. x ன்னு வெச்சுக்கலாம். total எவ்வளவு? 0.22 means number of moles of propane எவ்வளவு? it will be what? 0.22 minus x. the number of moles of methane we are calling as x. ஓகேவா? இது ஒரு வேரியபிள். இந்த x வேல்யூ நம்ம கால்குலேட் பண்ணனும். ஓகே, number of moles of propane will be equal to what? 0.22 minus x. இப்போ கேர்ஃபுல்லா அப்சர்வ் பண்ணுங்க. using the balanced equation, அந்த balanced equation ல இருந்து for every 1 mole of methane அதுக்கு will be requiring 2 times. எவ்வளவு ஆக்சிஜன் தேவைப்படும்? will be requiring what? 2 times, which means here இங்க x இருந்தா how much we are going to require? 2x நமக்கு தேவைப்படும். the amount of the number of moles of methane x moles இருந்தா then what is the amount of oxygen required? 2x. அந்த மாதிரி if you have 1 mole of propane அதுக்கு what is the amount of oxygen required? 5 moles, which means 5 times வருது. you are having 0.22 minus x moles of propane means அதுக்கான what is the corresponding amount of oxygen required? the amount of O2 required will be what? 0.22 minus x into 5. இந்த ரெண்டு நம்ம ஸோ இதுக்கு என்னது what is the amount of oxygen required 2x double இதுக்கு என்னது 0.22 minus x into 5 இந்த ரெண்டு amounts நம்ம add பண்ணா that should be equal to what given amount of oxygen தானா which is 0.71 moles பாருங்க 2 times of x எங்க இருந்து வருது we are putting let x is the number of moles of methane okay va and the corresponding balanced equation lende what are we having the amount of oxygen required is double the amount of methane okay so adukku we are putting 2 times x and what is the amount of propane here 0.22 minus x dana what is the amount of oxygen required for the combustion of propane and the 5 times the amount of propane 5 times amount anu sonna enadhi it is what 0.22 minus x into 5 and the total amount is what is the amount of oxygen what is it 0.71 இப்போ என்ன பண்ணணும் இந்த ஈக்குவேஷன்ல இருந்து நம்ம x ஓட வேல்யூ சால்வ் பண்ணலாம் x சால்வ் பண்ணா we will know what is the amount of methane அந்த மாதிரி what is the amount of propane okay so எப்படி x வேல்யூ சால்வ் பண்றது பாருங்க so எப்படி நம்ம சிம்பிளிஃபை பண்றது so 2x plus இதுல என்ன 0.22 into 5 என்னது that is what 1.1 what is it 0.22 into 5 எவ்வளவு is what 1.1 minus 5x is equal to 0.71 so இது என்னது 2x minus 5x எவ்வளவு minus 3x is equal to 0.71 minus 1.1 okay which means 3x value is what 1.1 minus 0.71 இதுல இருந்து x value will be what 1.1 minus 0.71 by 3 okay solve panna you will get the x value evladhu it will be 0.13 varum parunga what is the value of x going to come as 0.13 இப்போ 1.1 minus 0.71 எவ்வளவு தெரியுமா it is what என்னது 1.1 minus 0.71 எவ்வளவு it is 0.39 தானா 0.39 by 3 means what 0.39 by 3 means what 1.3 so x வருது நமக்கு we are getting the value of x okay இப்போ என்ன பண்ண போறோம் we got the value of x means we will know what is the number of moles of methane எவ்வளவு the number of moles of methane எவ்வளவு x தானா that is 0.13 அந்த மாதிரி number of moles of propane எவ்வளவு what is the number of moles of propane 0.22 minus x means 0.22 minus 0.13 என்னது what is this is 0.09 what is it 0.09 so add பண்ண என்ன வரும் பாருங்க 0.13 plus 0.09 that is going to be what it will be 0.22 so number of moles of methane நமக்கு தெரியும் number of moles of propane தெரியும் for every 1 mole of methane adukana what is the combustion energy 890 kilojoule per mole for every 1 mole of propane adukana what is the combustion energy 2220 kilojoule per mole okay so ipo namakku enna venum we are requiring what is the total amount of heat released in this particular combustion in the particular combustion la we require okay so CH4 oda number of moles evla 0.13 C3H oda number of moles evla it is what 0.09 okay so 1 mole of methane adukku what is the amount of energy released 890 okay so 0.13 mole of methane means what 0.13 into 890 dana this is the amount of heat released from the combustion of 0.13 mole of methane and madri if you are doing 1 mole combustion of propane adulande what is the amount of energy released 2220 but namakette evla what is the amount of propane that is there 0.09 moles dana so adukku corresponding amount of energy released is what 0.09 into 2220 okay va idu nama simplify panna we are going to get the value approximately as what 317 kilojoules varum approximately what you are going to get so eppadi pandrathu 0.13 into 890 okay adukku you have to add plus 0.09 into 2220 simplify panna adulande what are we going to get we will be getting the total amount of heat released adu evladhu 317 kilojoules paranga what is the correct answer for this option B is the correct answer ஸோ நம்ம ஒரு குயிக்காக ஒரு தடவை பார்க்கலாம் என்ன பண்ணியிருக்கோம்னு சொல்லிட்டு. ஓகே, ஸோ ஃபர்ஸ்ட் வாட் டு டூ, அந்த மோலார் வால்யூம் கான்செப்ட் வச்சு we are able to find out what is the total number of moles of oxygen. ஓகேவா, அது எவ்வளோ வருது, 0.71 moles. ஓகே, ஃபர்ஸ்ட் we have got number of moles of oxygen. அந்த மாதிரி சேம் மோலார் வால்யூம் கான்செப்ட் வச்சு we are able to find what is the total number of moles of the mixture. அது எவ்வளோ, 0.22. we are introducing a variable. இது நம்ம x எடுத்தா it will be what, 0.22 minus x. அதுக்கப்புறம் from the balanced equation வந்து we are relating the amount of oxygen required and the given value. The balanced equation வந்து we are getting what is the amount of oxygen required, right? And the x moles of methane kaga what is the amount of oxygen required, 2x. 0.22 minus x moles kaga for that propane what is the amount of oxygen required, 0.22 minus x into 5 times. And the total value will be equal to what, the total value will be equal to the total amount of oxygen which is equal to 0.71 moles. அதுலேருந்து நமக்கு x ஓட வேல்யூ வரும். ஓகேவா, x வந்தா that means what, number of moles of methane is 0.13 and number of moles of propane எவ்வளோ, 0.09. ஆல்ரெடி நமக்கு மோலார் கம்பஷன் வேல்யூஸ் கொடுத்துருக்காங்க. ஃபார் 1 mole of methane எவ்வளவு, 890 kilojoules. 1 mole of propane எவ்வளோ, 2220. இப்போ நம்ம கிட்ட what is the number of moles of methane, 0.13. so the heat released from that 0.13 moles of methane combustion எவ்வளோ, 0.13 into 890. அந்த மாதிரி the propane what is the amount of heat released, 0.09 into 2220. simplify பண்ணா நமக்கு எவ்வளவு வரும், it will be coming as what, 317 kilojoules வரும். ஓகேவா, next we will go to another question from 2012 paper. பாருங்க, standard enthalpy of vaporization, delta H vaporization for water. vaporization சொன்னேன்னு தெரியுமா, this is what, the liquid லந்து we are moving into the vapor state. அதுக்கு they are giving what is the delta H value and the evaporation happens at the boiling point which is 100 degree centigrade. Okay, so எவ்வளவு, 40.66 kilojoule per mole. The internal energy of vaporization of water, நமக்கு என்ன வேணும், we are requiring the internal energy of vaporization. means this is a question based upon what, and the del H and the del E order relation. Del H is what, for any chemical reaction or any process, right, we have delta H. what is delta H, the enthalpy change. what is delta E, change in the internal energy. so on the particular process kaga we have to look at what is the relation between them. பாருங்க, delta H எவ்வளோ, 40.66 kilojoule per mole. okay, and what is the temperature given to us, 100 degree centigrade, right? boiling temperature 100. kelvin la change பண்ணனும். kelvin change பண்ணா what is the corresponding value in kelvin, 100 plus 273 எவ்வளவு வரும், it will be what, 373. okay, இதுல இருந்து we are looking to find what is the del E ஓட value. so formula என்ன, del H is equal to what, del H is equal to delta E plus del Ng RT. del Ng என்னது, change in number of gaseous moles. okay, இதுல இருந்து நமக்கு del E வேணும். del E is equal to what, del H in the del Ng RT in the left side வரும், அந்த பக்கம் போயிடும். that will become what, minus del Ng RT. ஓகேவா, so del E ஓட value is equal to what, del H minus del Ng RT. okay, so இப்போ என்ன, the process is vaporization. vaporization என்ன தெரியுமா, the liquid is going to become vapor. so பாருங்க, H2O liquid is going to become H2O vapor, gas. product side la what is the number of gas moles, 1. reactant side la gas ஏ கிடையாது, it is what, liquid. so del Ng formula என்ன, number of gaseous moles in the products minus number of gaseous moles in the reactant side தானா, which means del Ng ஓட value is what, 1 minus 0. ஏன்னா product side the number of gas moles is 1, reactant side the number of gas moles is what, 0. அப்படிதானா, why, because reactant side la gas கிடையாது, it is the liquid. okay, so whenever you are calculating the del Ng value, adila we are not going to consider the solids or the liquids. okay va, so ipo enadhi, we have to just go and substitute. so del E is equal to del Ng க்கு பதிலா என்ன வரும், 1. so del E is equal to del H minus RT. இதுல ஒரே ஒரு இது தெரியுமா, if you are taking the R SI unit, what is the R value SI unit, it is 8.314 joule per mole into Kelvin. okay va, and the value of del H is in kilojoules. பாருங்க, the value of del H is what, kilojoules. ஸோ அதை நம்ம ஜூலில் கன்வெர்ட் பண்ணணும். எப்படி கன்வெர்ட் பண்ணுறது? ஜஸ்ட் மல்டிப்ளை பை 10 power 3 or 1000. ஸோ del E is equal to what? Del H which is in, ஸோ இது எப்படி நம்ம 40.66 into 10 power 3 joule per mole. ஓகேவா? we are converting this into what? Joules minus R into T. எதுக்கு நம்ம இதை ஜூலில் கன்வெர்ட் பண்ணுறது? பிகாஸ் R value is in terms of joules. இப்போ ஒரு டேர்ம் நம்ம கிலோ ஜூல்ஸில் எடுத்துட்டு அதர் டேர்ம் we cannot be having in joules. okay, so we should convert both of them either into the joules இல்லைன்னா into kilojoules. okay, so இப்போ என்னது பாருங்க, this is what 40,660 ஓகேவா ஜூல் per mole. இது என்னது 8.314 into 373. okay, அதுலேருந்து subtract பண்ணால் what you are going to get finally 37,559 joule per mole வரும். what is the approximate? ஸோ இதுலேருந்து தெரியுமா, இந்த ஆரில் per kelvin இருக்கா, இந்த 373 kelvin, இந்த kelvin cancel ஆகிடும். ஸோ செகண்ட் term also will be having what unit? joule per mole தான். so what is the value coming as? 37.559 kilojoule per mole. 37,559 in terms of kilojoules we have to express it, means what is it? 37.559 kilojoule per mole. so round off panna what you can say? 37.56. பாருங்க, what is the answer? option A. இதில் என்ன தெரியுமா, we have to be careful about the sign. plus minus signs also we have to be careful. ஓகேவா? இதில் என்ன வருது? what is the value coming as? plus. del H is positive and del E is also what? positive. ஓகேவா? so this is a straight question. ஒரே ஒரு தானேனா the phase change here, right? we are taking the del NG oda value is what? 1. so இப்படி நமக்கு ஞாபகம் வச்சுக்கலாம். whenever any question is given on this and liquid லந்து vapor, for that the del NG value will be taken as what? 1 நம்ம எடுக்க போறோம். ஓகேவா? and similarly in the case of sublimation, இந்த ப்ராப்ளம் கிடையாது, but if there is any question on sublimation, right, அதெல்லாம் தெரியுமா, we are going to become a vapor or a gas from the solid state. அதில் product, like say for example we are putting this CO2 in the solid state lende it is becoming what? CO2, because CO2 undergoes sublimation. okay, so CO2 in the solid state lende it is becoming CO2 gas. so in this case what is the product side? gas moles 1, reactant side solid, we don't count it. so adiliyum what is the value of del NG going to be? 1. okay, sublimation case also, right, we will take the del NG value as what? 1. okay va? so we must practice all these things. Another question paranga, this is the question that has come in the 2011 paper. if the enthalpy change for the transition of liquid water to steam எவ்வளவு? 30 kilojoule per mole at 27 degrees Celsius, the entropy change for the process would be. so என்னது? liquid லந்து it is becoming into steam. what is this? evaporation தானா? is what? evaporation. so delta H evaporation எவ்வளவு? what is it? 30 kilojoules per mole. okay, we can write it as what? 30,000 joule per mole. 30 kilojoules means what? 30 into 10 power 3 joule per mole. okay va? so del H is there. the corresponding temperature, boiling temperature எவ்வளவு? 27 degrees centigrade, means what? 300 kelvin. இதில் நமக்கு என்ன வேணும்? delta S for the entropy change for the process. this is what? phase change தானா? remember we discussed, இதுக்கு முன்னாடி ஒரு problem we discussed about it. for any phase change, entropy change for the process, அதோட value is equal to what? delta H for that phase change, enthalpy of that phase change, enthalpy change for that phase change process divided by the corresponding temperature. okay va? பாருங்க, the del S oda value is equal to what? delta H divided by temperature. delta H எவ்வளவு? 30 into 10 power 3 joule per mole. okay, temperature is what? 300 kelvin. divide பண்ணா what is the numerator? 30,000. 30,000 divided by 300 எவ்வளவு? 100 தானா? so 100 joule per mole per kelvin. so what is the answer? option D வரும். 100 joule per mole per kelvin. இதனது? this is what is the entropy change for that phase change process. so நீங்க பார்த்த நிறைய தடவை இந்த entropy change calculation in the phase change is asked. அதுக்கு ஒரே ஃபார்முலா என்ன? for any phase change entropy change is equal to what? enthalpy change for that particular phase change process divided by the corresponding temperature. Okay va? So this is our part 2 of the video, and we will see in the part 3.